Let's work on classifying these quadrilaterals, and we want to give the most specific name that we can, and this is one topic that students have a lot of trouble with because they want to say, well, this figure to me looks like a rectangle, so I'm going to call it a rectangle, or this looks like a square, so I'm going to call it a square. And unfortunately, we can never go by what a figure looks like. We have to use properties, we have to use proof, we have to use evidence to support what we're claiming. And so when I do these problems, I kind of think of them as looking for clues. So I want to see what the problem is telling me and then use those clues to help figure out what this figure is. So the first thing I do is I figure out which property the diagram is trying to show me. And so in this first figure, what I'm noticing is I see a bunch of angles. So I would probably look at all my properties that involve angles. And specifically what they're showing me is that this diagonal is bisecting this angle. It's cutting that angle into two equal pieces. They're both 31 degrees. And same all the way around this figure. And so what I typically do is I actually write down that part first. So I write down my clue, my evidence. My clue is that diagonals bisect angles. And so what I would do then is look at my properties chart, and I would look up what figures have that property checked off, diagonals bisect angles. And I believe you're going to find two. I think one of the properties that has that checked off is going to be the rhombus, and the other quadrilateral that has that property checked off is going to be the square. And so we have two suspects, I suppose, two things that this shape might be. If I want to prove, my default's going to be a rhombus, because a square takes a little bit more proof to do. A square is a very specific shape. So I would need to be able to show something else to get this to be a square. If I can't show that, I would have to default to rhombus. Or there's more things you might want to look for to eliminate one of your choices. And so what I'm noticing is that these angles are not 90 degrees. Like I can see, or if I add those two angles together, I can see that's not going to be a 90-degree angle. And I know that a square has to have 90 degrees, so this figure can't possibly be a square. Therefore, it must be a rhombus based on the fact that diagonals bisect each other, or diagonals bisect the angles, and that the angles are not right angles. So this figure is going to be a rhombus. Let's try the second one. Again, take a look and see what clues the diagram is giving you. This time what I'm noticing is I have 4 right angles. Okay, so I'm going to write down my clue first. I've got 4 right angles, or I could say all angles are congruent. Both of those things kind of mean the same thing. So all angles congruent, or all angles are right angles. Again, take a look at your properties chart and see which shapes have that property checked off. All angles congruent, or all 4 right angles. And again, there's probably going to be 2. There's the rectangle, and there's the square. The square is going to show up a lot because the square has almost all the properties we've talked about. So there's 2 options. Again, my default name is going to be a rectangle unless I can prove something more specifically to get this to be a square. And so I'm going to look back at my figure to see if there's other things that this is showing me. We know that a square, in addition to having 4 right angles, also has 4 equal sides. And I can see that my sides are not the same. One's labeled x, one's labeled 2x. Since the sides are not all the same, again, I can eliminate square as an option. It's not going to be that. So this figure must be a rectangle based on the fact that it has all congruent angles. Next up, let's see what we've got. Again, take a look at what the properties are showing you and use that as clues to help figure out what this is named. What I'm noticing this time is right in the center I have a right angle, and it's the diagonals that are at a right angle to each other. So I'm going to make a note that diagonals are perpendicular to each other. Okay? Again, take a look at your properties chart and see what options that could be. We have a rhombus as an option that has perpendicular diagonals, and again we have the square. Rhombus is my default unless I can prove something else to eliminate rhombus as an option. And so there's one other thing this diagram is showing me. They're showing me that diagonals bisect each other, which is helpful, I guess, to note. But if you look at your properties chart, all the parallelograms have that property. So that doesn't help me differentiate between the rhombus and the square. However, if I look, not only do the diagonals bisect each other, all the pieces of the diagonals are the same length. They're all 2's, meaning both diagonals are actually the exact same length. They're both diagonals that have a length of 4. So that's a separate property. That's the property that diagonals are congruent to each other. So at this point we have some more evidence to look at. So take a look at your properties chart for the rhombus and for the rectangle, or for the rhombus and the square. One of those should have the property diagonals are congruent to each other in addition to diagonals perpendicular. The only one that has both of those properties is the square. So this time I do have enough evidence to prove it's a square, but I would need to show both of those statements were true, which I can see in the diagram. Okay? And last up, once again, I want to take a look at what is being shown to me in the diagram and then use that to help figure out what shape this is, what quadrilateral this is going to be. So what I'm noticing is I've got 4 congruent sides this time. The tick marks show me that all 4 sides are congruent, meaning if we check our properties chart, I could have a rhombus right here because a rhombus has 4 congruent sides, or it could be a square. Once again, rhombus is my default unless I can prove something else to get it to be a square, or maybe I can eliminate square. In fact, I can, because once again, we have that idea, look, our angle, if this was a square, that angle would have to be 90. I mean, that's what a square has. So because I have an angle that's not 90, I know this can't possibly be a square. The only name I can give this is going to be a rhombus. We can also do a real-life example for why this would be useful to know what shape we're working with if we think about construction. If we're building something, we definitely want to make sure that our angles are right angles, meaning we're working with squares or rectangles. If we're building a window frame, for example, we want to make sure that that's got right angles. So the first question up here is saying, let's say we want to test if this is a rectangle, and so we've measured all 4 sides. And we can see that the top and bottoms are the same length. And we can see that the left and right sides of the window frame are the same length. And I want to know, is that enough evidence to prove that this is a rectangle? If I take a look then at what we have, the property that I'm being shown is that opposite sides are congruent. So taking a look at your properties chart, does that prove that this is a rectangle? Is a rectangle the only parallelogram that has opposite sides congruent? And the answer, if you look at your chart, is obviously going to be no. All the parallelograms have opposite sides are congruent. So I don't know if this is a rectangle or not. I know it's not a square or a rhombus because the sides aren't all the same length, but this could be a rectangle because a rectangle does have opposite sides that are congruent, but this could also just be a parallelogram. I don't know that for sure, and because I can't prove, oops, too many L's in one spot. Because I can't prove anything further just based on the sides, I have to default to parallelogram. That's my less specific name. So I don't know just by measuring the sides that this is a rectangle. That's why when people are constructing, they don't just measure the sides. So let's go one step further, and this time let's say we've measured the diagonals. And so now I've measured diagonally from one corner to one corner, and I see that the diagonals are 54.8 and 55.3. So my diagonals are not congruent. If you take a look at the properties of a rectangle, you would see that that should be checked off. If we're working with a rectangle, the diagonals should be congruent. So my conclusion is that this is not a rectangle. In fact, it was a parallelogram. So what I would need to do is I would need to kind of bump the window frame a little bit to the right or left in order to get those diagonals to be the same length. So I would be working with a rectangle. But based on the fact that we have diagonals that are not congruent, this is definitely not going to be a rectangle.